All right, which one?
Number 29. 19. I couldn't get it.
No, I couldn't get the bottom part.
I was literally going to the top.
Okay, so let's do 19, then we'll do 20. We'll go in order. All right, number 19. Y equals, oh, gross.
I thought we were going in order.
We are. They said 20 and 19. We're not doing all of them, man. We did a lot of them yesterday too. Okay.
Hey, what? Okay. This was the homework for last night.
Yes, correct. So we're asked to find dy dx. Yes. I am going to have to use the product rule as well as the quotient rule here. All right. Well, you're going to have to do the quotient rule, but it's got the product rule embedded in it, if that makes sense. All right, so watch. We do, yeah. You can't just do the derivative of the top and the derivative of the bottom, though. All right, watch. Well, there was, and I had a typo on it, and I took it from you and chunked them, and I haven't fixed it and ran them yet. Custodians picked it up. It really makes me angry too, man, that they do their job. I don't know. All right. Remember the quotient rule. So if you want the quotient rule, if you have u over v, it says we do the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So d dx. Ooh, what are we going to do? All right, derivative of the top is going to be your hardest part of this entire problem. So derivative of the top, well, if I want to take the derivative of this, I have to do the product rule. So the product rule says I do the derivative of the first. So remember, if I'm doing the product rule, I'm doing derivative of the first times the second plus the first times derivative of the second. So derivative of the first is 1 times x squared plus x plus 1 plus the first times derivative of the second. You could do that if you wanted to.
This is called the product rule, correct?
All right, this is the product rule of that. So that is derivative of the top times the bottom. That's what the product rule.
Oh, I did not have that.
Do what? Yes, you have to. So it's got to be derivative of the top times the bottom minus the top times derivative of the bottom. All over the bottom squared. And yes, Katie, that may be an easier way to do this.
When did you get the derivative of the top times the bottom? I thought it was the first times the second and the second times the first.
For product, yes. This is quotient, yes. Whenever we are going to get into so many embedded things where you have to, but yes, you have to because, all right, and let me write this here. Remember, let me rewrite it because I had to erase it. The derivative of u over v is derivative of the top times the bottom minus top times the derivative of the bottom all over the bottom squared. Well, to find the derivative of the top,
Got it. Ladies and gentlemen, who's familiar with that render mode?
You can't just find the derivative of the top and then just substitute a derivative up here, if that makes sense. No. So if this is u and this is v, this is the derivative of the top, and to find that I had to use the product rule. This is the bottom. This is the top, and this is the derivative of the bottom.
Okay, so what I see,
Yes, remind me.
so what most of us did, what I did was, what I figured most did, you did the whole top, and then wherever you get the top, you put it over.
So you only did the derivative of the top.
So it's the entire derivative of the top.
Now, what Katie is telling you that she did may be easier for you. Okay? She said, because here, understand what I have to do here now to finish. I'm going to have to FOIL. I'm going to have to combine like terms. I'm going to have to distribute this. Same deal over here, and then clean it up. But I could take this problem the way it starts, and I could say, well, I'm going to do, if I have x minus 1 times x squared plus x plus 1 over x cubed, I could just go ahead and FOIL this out up here. So that means y is x to the third plus x squared plus x minus x squared minus x minus 1 all over x cubed. X cubed minus 1. Oh, wow. So now if I do dy dx, yep. Derivative of the top is times the bottom minus the top times derivative of the bottom. All over the bottom squared.
So you can follow this first.
Yeah, sure. You can do manipulation first before you evaluate the derivatives.
Because that was so much easier.
Although they set this up for you to use the embedded, because sometimes you can't. Sometimes you, I mean, if that was cosine x times,
This worked because they were all.
it was polynomials, yeah. Do it. Then he shakes his mouth. He goes, She does commercial.
Yeah, but I saw it from Family Guy, and then like the thing of the guy like snorts a lot of cocaine, and it's like it ain't easy. I'm not.
Family Guy takes a lot of rough this book.
Yeah, let me.
Watch these signs as you go. Watch your. So the answer is, let's see. Oh, those are gone. So positive 3x squared over x to the 6th. Is that what you got?
It's really, really fun.
Yes. Let me do 20. Somebody asked about 20. Again on 20, if you wanted to distribute out first. Oh, you couldn't. The negative 1 exponent means it's a fraction. So it means this is really 1 minus x over 1 plus x squared. So to find dy dx here,
a little like, because you put that thing on the bottom.
Because the -1 exponent. That means put it in the bottom of the fraction and make it positive.
X minus 1. Let me write that down.
Yeah, write that down.
I did take a -1 out.
Wait, what?
On the bottom, factor.
No, because it's not 1 minus x squared. That's only difference of two squares. It doesn't work for a sum of two squares. Still wouldn't work because you've got the x squared. Y'all are trying really hard to simplify this down, but it is simplified. No, it won't simplify any further. I got to do quotient rule, which is derivative of the top, -1, times the bottom, minus the top, times derivative of the bottom, x, all over the bottom square. Clean it up. -1 minus x squared minus 2x plus 2x squared. All over. I'm going to go ahead and FOIL this out. 1 plus 2x squared plus x to the 4th. Because you just square the ends and you put these together and double it in the middle. What? It's sorcery. Yeah, that's fine. Did anything cancel if you didn't FOIL it out? It doesn't matter. You can leave it. No, that's perfectly fine if you left it there. I would clean up the top. Factored form is always okay form. That would be, let's see, x squared minus 2x minus 1. And if you left it that way, that's fine. That doesn't factor, so it's fine.
Wait, can you tell me what you mean by square? So you square x.
So anything you have that's FOILed, give me a binomial, any binomial in the world. Make it as hard as you want to. 2x.
Okay, sorry, but what is easy to make it easy?
Square this one.
2x squared.
Close.
Oh, sorry. 4x squared.
Multiply these two together. Now double it. Square the last two. It's a backwards perfect square trinomial. Other questions on your homework? 30 and 31. These are so much fun. I could just work these all day long. I love them. I just love them because the algebra. I love algebra. Yeah. So I did when I gave you the rules yesterday. I didn't say anything about negative because negative exponents still operate the same way positive are. There's no stipulation on fractional exponents, negative exponents. It doesn't matter. The power rule works for all exponents. So in other words, remember this is the same thing as 1/4 x to the -4, right? Right. X. This is the same thing as this. You agree with that?
I would agree with that statement.
What?
There's a 1. There's an invisible 1 right there.
Yeah, I'm just showing you that we could really write it this way. Just so you see why what's happening is happening. So the power rule says, take the exponent, bring it around front and multiply, right? And subtract 1 from it.
So it would be negative 4x. No, negative 1x. Negative x.
It would be negative.
Negative x
To the third.
to the negative fifth.
Minus 1.
Now do it again.
All right, hold on. Let me do this one.
Okay.
X to the negative 4.
That's always. But what?
The power rule says, bring the exponent around, multiply at the front, and then subtract 1 from the exponent.
I need a pencil. It's plus.
So it's plus, because negative and minus, x to the what?
Isn't that now a positive 3? Because 3 times negative 1/3. Wait, negative 3. Wait. Oh, yeah.
Where are you confused? All right, look, let me write this. The derivative of x to the n is n times x to the n minus 1. It does not matter if n is positive, negative, fraction. It doesn't matter. It works for any n. So here. Because x to the negative 2 over 2 is the same thing as 1/2 x to the negative 2. Like I could make this 1/2 times x to the negative 2. If I put it back as a one single fraction, it would look like that. No, you didn't. Remember, the derivative of a constant is 0. You want me to show you how it works? Let me finish it out this way, and then I'm going to do it for you with the difference quotient, show you that it works. Minus x to the negative 3 plus, that's times 1, right? So I'd have plus 1 x to the 0 plus 0. What's x to the 0? That's 1. So this is the derivative. Lizzie, if I had done difference quotient, if I have x to the negative 4 over 4, sorry.
Isn't this better than an $8 drink?
It's a 50-cent heart attack.
That's funny. That was probably like $2.
This ain't $2. This is what?
Which part, Lizzie?
That was like $1 total. And Meg spent $8.
Exponents always go down 1.
And they called it revolution.
They're giving you a real hard time. You don't care, do you? It is really good.
She's gonna beat me later.
Don't even like experiment. The girl's energy. Just forget.
So Lizzie, what I would do is, if I'm doing the derivative here, derivative of the top, that would be negative 4x negative 5 times the bottom minus the top times derivative of the bottom is 0 all over the bottom square. This is 0. 4 times negative 4 is negative 16, x to the negative 5th, over 16, which would be negative x to the negative 5. Thank you. Other questions on your homework? 31 and 32. Oh my goodness, 31. Okay. You worked on it that long?
That's only an hour.
She says not to do that. She says don't do that.
That's an hour and 45 minutes.
Change square root of x to an exponent for me. 1 over 2 minus 1. Is exponent 1/2.
She was like, the bell. It was like the bell.
What's that work though?
I'm sorry. Ring back. What? You didn't hear me?
Radical dude. Where the 2 goes on the bottom.
All right. Derivative here. Quotient rule. Derivative of the top. What's the derivative of x to the 1/2 minus 10? Same rule. It's still in x to the. All right, 1/2 x negative 1/2. That's exactly right. That's the derivative of the top times the bottom minus. What's wrong, Noah?
She worked on this very hard.
Van's gonna score. Where did it go? Y'all, where did it just go? Okay, the derivative of x to the 1/2. Bring the exponent around and multiply, and then subtract 1. 1/2 minus 1 is.
Write that down real quick.
Over the bottom squared. Y'all are going, oh my gosh, on this. Wait till we get to chain rule. Y'all are really going to go, oh my gosh. But that's what throws everybody. All right. I'm going to leave the bottom like that until I see if I need to, but it's a foil, so it'll be easy to, it's a squared. It'll be easy to, right? Square the first, square the last, put them together, double them. But I'm going to leave it right now. Well, 1/2, x to the 1/2 times x to the 1/2 would be just x.
So x?
Okay.
I'd just be better off.
What do you get? All right, let's think back. When we multiply terms, we multiply the coefficients, and we add the exponents on x. What is negative 1/2 plus 1/2? 0.
So it's 1.
So it's 1. Which means this is just 1/2, yes? Gross. Well, if it ain't Dylan. All right, so that's gone. Come on in here.
Okay, for 8:30.
Plus.
I looked over and I was like, oh my God.
1/2 x to the negative 1/2. Yes or no? All right, minus. So really, I'm distributing a negative 1/2 through here, right? So minus 1/2 x again to the 0, so it's just minus 1/2. I got a negative and a negative, so this is going to be plus, and multiply it by 1. When you bring what down?
You bring 1/2 down, you do something to the exponent.
Subtract 1 from it. You talking about when you find the derivative? No, what are you talking about?
Like we take x 1/2.
Here?
Bring exponent down. And then let's say you subtract, when you bring it down, you subtract the exponent, or you just subtract.
Where did I bring it down? I think I'm confused on what you're asking me. So whenever I did this, I added the exponents together.
I mean, like, let's say x to the 1/2, right? Bring subtract that exponent yourself, or you
Subtract 1 from it. All right, I have some like terms here. Those are gone. Look, that's nice, right? 1/2 x to the negative 1/2 and 1/2 x. So what does it become? It becomes x to the negative 1/2, a whole one, right? Over x to the 1/2 plus 1 squared. You could leave it like that. I don't know how the answer in your book put it. I don't even know what number we're on anymore. Just bring it down. Because it's a negative exponent. If you wanted it back in radical form, since that's the way the problem started. Same thing. Tell me when.
When you combine those 1/2 x negative 1 over x, what if you just leave the exponent as negative 1/2?
When you combine like terms, okay, don't get thrown off. If I had 5x squared plus 3x squared, you would say that's what? 8x squared. So you leave that exponent alone, right? Same thing here. Leave the exponent alone and combine the coefficients. Don't apologize.
No, man, you shouldn't.
Don't be sorry, Van. It's okay.
No, I'm almost 40.
Other questions? 32. Oh, that's another good one. I love these. I just can't tell y'all. They're my fave. Once you get the hang of them, they're really not bad. Again, I'm going to change these to 1/2 exponents because I'm going to be using the power rule. So I'm going to make this 2x 1/2 minus x negative 1/2. Can I do that? Sure. It's in the bottom, so just make it a negative exponent. Power rule. Say again. You don't even have to use difference there. You just use power rule. 1/2 times 2 is 1/2 minus 1 is. Bring this around. I've got a minus here, so it's going to change this to. Because I multiplied by negative 1/2. Now I've got negative 1/2 minus 1. What is it?
Negative 1.5.
Which is,
Negative 3.
where did I lose you? I just did the power rule. Multiply in the front and subtract 1 from the exponent. Negative 1/2 minus 1 is negative 3. I just leave it just like that. Sure. Is this confusing? Let's take a brain break before we start today's. At these rules. These, not these, these. These rules. Yeah. This whole section is just these derivative rules. More derivative rules.
And then can we have a major quiz
We're gonna have a major quiz after this section.
Is it like another section?
Probably like Tuesday.
We know when, because I have.
I'm gonna say Tuesday.
Dude, Monday quiz is like the best though. You can study all week.
I've never studied on the weekend a day in my life.
I don't know if
These type problems remind me of when we did function composition and everybody finally got function composition, and then I did composition at specific points and everybody's like, oh my god, that's so hard. But oh my god. So yes, I am. Yeah, well, but I'm just saying, for example, if I had a function u and I plugged 2 in for every x, I would get 3 back out. If I had, so I'm defining these functions ahead of time at these points. This is number 24 from your homework tonight. It says, suppose u and v are functions of x that are differentiable at x equals 2. And u of 2 is 3, and so on and so forth, and everything. Right. Find the values of the following derivatives at x equals 2. And so part A says, what is dx of u v? This is just testing your knowledge of the derivative rules. It's just the product rules, the product rule here. What does that say? You can't just do, this does not equal the derivative of u times the derivative of v. What's the rule?
I lost my sheet.
Derivative derivative of the first times the second. Yes. All right, so now we're just going to plug in. So the derivative of u would be negative 4, because it did tell me at 2, times 1 plus u, and I'm just getting this from the information that was given.
Wait, could we do the reciprocal of the prime and figure out what it is? Let's say if we had prime of 2, we would know that would be x to the. Wait, no.
These were defined for me to start with.
Couldn't we find if we had why did I say if we had the derivative of something, couldn't we find what it is using the derivative?
No, we would have to use the integral, and that's the second half of calculus.
You couldn't do the reverse part of a derivative? You couldn't reverse it? No?
You can reverse it. It's called an integral, an antiderivative.
That's the second part.
Yes, I'm sorry. All right, you try this one. What is the derivative using the same information of u over v?
24, right?
Yes. There's 4 parts.
I mean, we still have to see more of it. We need to see this. It's all right.
So the answer for the other.
The whole point of the I need to see this. What about you?
Oh, it's negative.
You get the right sign, yeah. They're not negative. It's negative. It's definitely negative. It's negative.
What about get negative 10?
Some of us.
So,
I'm not saying no.
yes, because somebody said just that was initially what they wanted to do was just do negative 4 times negative 2. But you can't do that because derivative rules don't let you do that. I'm going to skip C because it's just like B, but let's do D.
We couldn't figure out 16 last night. It was like U to the negative or something like that.
Try this one. So now the question is, can you separate them? Because we couldn't separate this with multiplication, just do the derivative. But if you're adding and subtracting, can you?
Wait, so we're talking about the derivative of what?
All of that.
We're not using those numbers?
Yeah.
Well, we're plugging it in.
The sum/difference rule says you can.
Oh, you already know what. You already know what.
You're not plugging it. You can't plug in for U here because this is not. You have to take the derivative first. So this would be the derivative. What I'm getting at here is you can split it up this way. So this is 3 times the derivative of U. Right? I'm taking the derivative. The constant multiple says I can bring this 3 around front. Yeah, 3U. 3U.
Well, it just goes away because you have 0 for the x number.
No, you're thinking, I'm telling you that U is a function. It could be that U is 5x squared plus 2x minus 3. I don't know what U is. It's a function though. So I need to do the well, it tells me up here because I'm doing it at 2. So up here, remember, I have it defined. I know what the derivative of U is at 2. Yes, yes. All of these are done at 2. Minus, again, I can pull the 2 out front and just do the derivative. This is the one that's going to be a little bit harder. Because it's U times B. So what do I have to do?
You gotta do the product.
The product
We
rule.
already did it though, so.
Right.
Oh my
Derivative first.
We can just pull it down our answer from there.
You can just pull down your answer from A. So part A told me that this is 2. What's the derivative of U at 2? Negative 4. How about V?
I guess it over.
2.
What's the derivative of
I know the answer. We didn't pray. All right, so you'll have one like that where it's just testing your properties. Okay. Yeah, because that was the product rule off of your sheet.
No, not that. I mean, what, the 3U prime.
Because if I do the derivative of 3u, the constant multiple says I can put the 3 out front. And then I would have 3 times the derivative of u. Well, the derivative of u.
What's the way to write that?
Right. All right?
You know, you said they be like used interchangeably, and I almost didn't believe you.
What about dy over dx? I forgot how that changed things.
No, one portion where it's like u prime equals u. Like, what's the difference between the two where it's like u prime and plus u prime?
This is just using the product rule to expand that.
We're going to use this on our little quiz thing.
Because we've only learned like 4 or 5 properties. All right, let me go through because I want to make sure you're set up for your homework tonight because we're not getting through too many too fast. Number 28. Directions for this one say, find an equation for the tan line to the curve at the given point. You have done that before. You used IROC and we did the limit. As h goes to 0. We did. You're exactly right. So, now you gotta do this with my hand. I know, I'm sorry, Leah. But, yes, that's exactly what I'm gonna do. I'm gonna find the derivative at -1. And that is gonna be the slope of my tan line, right? Because that's just a shortcut for doing IROC. And then y of 1, or y of -1, I'm sorry, would be nope, 3 over 1, so it'd just be 3. That's my point, -1, 3. I'm going to have a point and a slope to write the equation of the line. But to find the derivative, this is a fraction, so I'm going to have to use what? The quotient rule. Derivative of the top times the bottom minus the top times derivative of the bottom, all over the bottom squared. You'd use power rule in that. Y'all need me to set it up for you real quick before I go. So always start with the derivative of the top. So what's the derivative of the top here? 4x cubed times the bottom minus, I plug -1 in here just so I got a point.
Then you got minus.
Okay, I'm going to do x to the 4th plus, just because that's what I'm used to doing, times 2x. You just did it, you just flip-flopped them in this.
2 out of the first term?
2 out of the first term where? What's the derivative of a constant? But remember, I need the derivative at -1. So I might not even clean this up before I plug -1 in, because it might be easier just to plug -1 in the way it is now. I agree too.
It was 2, maybe not.
Right, but 1 at -1, that would be 4 times -1 cubed times -1 squared. But if you want to do it, I don't know. Yes. So now I just write the equation of a line given a point. But don't you think that that was way quicker than doing the difference quotient? Because I plugged -1 in the original equation. Since, remember, that's always what you want to do. Well, since it says the tan line at -1, you have to use -1. You use -1 for your derivative and your original function. I listened to Aaliyah. Who said Miss McGee? I don't even know what that is.
I would never learn a single thing. I'm happy that never happened last year because I probably would have.
We did that one time with Miss Madden last year, but yeah, you should have seen our conversation.
No, I would not.
If Miss Robinson tried to do that, I could probably see that be something.
What if you want to write notes? You can't? You have to draw them? How can they make you draw them? Or she giving you a grade on it?
And Miss Vaz is definitely grading every single thing you do. Miss Bates? Oh, Miss Bates? Miss Vaz, we grade everything.
What if I asked you to find the values of x for which the curve has horizontal tangents? What's 0? The slope. Okay. Find the values. Find the values. This one's going to be deep in algebra. Find the values for x for which the curve has horizontal tangents. There you go. That's what I wanted you to say.
So if the derivative has to be 0, then
Wait, what's 0 in the denominator?
constant would be gone.
A what?
All right. How am I going to go about this?
I would, that's a great question, Miss McGee.
How? You set y equal to 0?
No, you said y prime.
You set the derivative equal to 0. So I need to set this equal to 0 and solve to find my horizontal tangents. And they should occur, let's see how well you really understood this. They should occur at what points of the graph? Somebody get it. Please, somebody get it. Good job, Aaliyah. The maxes and mins. The horizontal tangents are going to occur at the maxes and mins. Exactly. That's where your slope levels out. I'm so proud, Aaliyah.
Take a load of these.
Okay, so the first.
What you gotta do is take a load of these.
I'm gonna let you finish that one. I want to make sure you're set up and you can do all your homework problems. So you'd find the derivative, set it equal to 0, and solve.
Once you've got all your derivatives, set it equal to 0.
And solve for x.
Like, how do you suppress if you don't have all like terms?
Well, so your derivative, 4x cubed minus 21x squared plus 4x, if that equals 0, how do you solve that? I would start by taking a GCF out and then factoring.
Take out x.
Take out x. Then you'll have a quadratic.
Take out x, then take out 4. Then take out another x.
You can take out 4.
Come on, dude.
Wait, 16.
6 multiply 16 adds to 21. You might have to do the quadratic formula.
Huh? I don't know. I'm so serious. I don't know quadratic.
This is a quadratic formula problem. If you can't remember it, here you go. You do want to commit this one to memory. Can you keep taking derivatives?
Taking the derivative of the quadratic formula.
Like,
So you're saying you take the derivative? You can.
Take the derivative of that for me.
Wait,
Tell me what you
can do
get.
it twice. You can take the
Can
derivative.
you?
Yes, you can. I know.
What? Okay. What would you get?
Hold on.
You get X.
Just take the derivative.
You get X. You get X.
No, I left it for you to do.
You get 4. You would get 4.
No, you get X.
We have to move on. If you literally put it in the
Obviously, b plus or minus the square root of b squared minus 4ac. I don't know what 21 squared is. Thank you. And then what's 441 minus 64?
That's the answer.
Please refer to me from now on as the Golgi body.
What about the X?
You can leave it like that.
What about the X?
Remember, there was also an x equals 0. What about it?
There was an X on the outside of the parentheses.
That's where my x equals 0. So here's 2 and a third. There's a cubic, so I should get 3 answers.
There's a little X on front of X. That's just how you use it.
Yeah, this went to 0 also. And this equals 0. Quadratic formula takes care of that.
Yeah, wouldn't it have to be a constant as the Wouldn't if y prime is
Okay,
0,
it's not, this is, if the derivative equals, if the derivative itself is 0, yes. But when it's 0, the slope of the tan line is constant there, so it's happening at the top of the maxes and the mins.
I understand that, and I know like each individual derivative might not be 0, but shouldn't the entire derivative of the entire function should that be
At those points, yes. At those specific points. Quickly, what's the derivative here?
I told you that.
I said it, bro.
I think it's
2x plus 1. Do it again.
3.
Could I do it again?
It's definitely
0.
What does that mean?
The derivative
of that to the right power.
Why are you telling us this?
Because I'm setting you up
For
for something else we're gonna do.
integration.
All right, let me put your homework up here. This is actually 129 to 130.
Hey, where's that sign? That is hard, so it's right. Get over it.
These is also.
And they're just gonna give us like 2 totals. He's gonna just go through the rest of the
Okay, we got 1 minute left of class.